Yeah, so my name is Billesoe Beck. So I'm head of the Innovation Lab at Universal Robots. So Innovation Lab at Universal Robots is a fairly new department at Universal Robots. It's actually, for once, not a commercial or a research unit, a corporate research unit, as you see in a lot of other major companies. So Innovation Lab at UR is a department to handle sort of pre-roadmap technologies. So we still staff them with R&D teams to massage ideas, to prepare ideas, before actually bringing it into the main R&D loop. So it's a department primarily staffed with engineers that we already have, and looping it through and preparing ideas and preparing concepts for actual implementation. What we also do is support research collaborations, research work, and that's also why I can share a bit about the ROS support here. So as Mirko said, ROS as Universal Robots have been supported in ROS since, I guess, quite early after the release of the UR robots. There's a lot of robots used for research. It's been mostly community-driven, so there's been a lot of drivers, and I guess throughout the years, a lot of stuff had happened, but there's a lot of UR robots used in research. I guess we can all agree that there's still large potential in growing and using industrial robotics in research and in development based on ROS. Is something that we would definitely like to see more. So we'd like to see more robots in the factory floors, supporting doing all the stuff that we don't want to do. But we also see ROS going in many more other directions, right? So ROS can also help getting more robots into doing stuff like that, or doing stuff like that, or doing stuff like that, right? So there's so much potential in still exploiting our robots and also sidestepping into other businesses. And building upon something like the ROS ecosystem and the research going on there has a great potential of growing technologies, both for the industrial application areas, but also for a lot of application areas beyond the industry. So we've decided also to step in and try building up a new ROS driver to make sure that we have the support properly. So as you probably know, and we even heard it mentioned this morning, that especially in the last few years, the landscape of ROS driver support for the Universal Robots have been a bit clouded, as you can say. I think we are counting more than 200 different variants of the existing ROS drivers, and there's definitely even more of them in shelves all around in research labs. And a lot of them has also proven a bit unstable towards API changes during the time, especially the last couple of years. Tend to see it breaking often. So in the end, it also gave a really bad user experience on using ROS with the current drivers on the UR robots. So, and on top of that, we also want to tackle a bit of improvements here and there. There's a lot of features that could be improved. There's a lot of especially new stuff coming in that we want to support. Performance could also be improved, and with the eSeries, there's a lot of new features that we want to support. So we paired up with in the ROS-In project together with FCI that has a long track history, is also developing ROS interfaces to a lot of robots, and we'll be doing this in the scope of ROS-In to really build in a new ROS driver that hopefully tackles a lot of these issues. All right, so let's dive into it. So we want to make sure that the new robot driver, as it is the goal of any UR robot, to have an ease of use and be as plug and play as possible. So that's really a key important thing for us. It's always been so that at least as long as it worked, you could actually unpack a UR robot and get it running with ROS within a few minutes. We want to get back to that, right? So that's really an important thing to make that easy. But still, we want to get the performance up. So we want to have all the features that the robots do have available for you guys, so you can experiment with it and really get the performance out of it. And we also want to make sure that the interface will be as industrial grade as the current ROS practices really allows it to be, right? So handle the stuff about real time, handle the stuff about how do we do with safety and so on. Because in the end, if we want to have more of the application that I showed you in the beginning, we need to be able to sort of compartmentalize stuff that we do in ROS, but also build it in a way that we could bring it closer to market commercialization, right? We want to build it on top of stable APIs, so we won't get the driver breaking all the time. We will integrate it into the software test engine of UR, so make sure that we do recursion testing all the time. So if we accidentally at UR break something, we'll actually know about it before we release the software. We'll remain it open source, so hopefully also we can get some support from you guys in the community also to make sure that we can keep it stable towards any API changes in ROS, and perhaps even get some collaborative rebuilding and improvement of the features. So, one of the key things we want to change is that the classical way of using the ROS driver with a UR robot is what we call the remote control concept. So pretty much you launch a piece of script on the UR robot and it becomes a slave to a ROS machine. We want to keep that. There's a lot of stuff that's been built on top of that, and it works really well if you want to do research into, let's say, easy programming, or if you want to do more like on an OEM solution where you actually don't really need to interact with the robot programming environment by itself. I think the new thing is we want to support it completely then, because then in the end the teach pendant becomes an annoyance that you have to go back and forth between the teach pendant. So the new driver will allow you sort of to run completely without the teach pendant. You can even unplug it actually on the eSeries. So that would give you the opportunity, if you want to do something that approaches more of an OEM solution, then you can actually go all the way there. So you can start the robot and unlock the brakes and so on in the ROS driver. The thing that I think we are a bit more excited about is we'll also implement it as a UR-CAF functionality. So the challenge with the traditional way of using the ROS driver is that ROS will take over complete control of the robot, meaning that if you're really good at doing bin picking, or if you're really good at just if you're doing vision-based research, then all the other stuff that you would have to do with the robot, you have to sort of implement that yourself on the ROS side. So here the idea will be that you will have a ROS control feature in the programming tree when you're programming on the robot. So you can actually have a classical robot program that does the insertion of a part or does whatever handling task you want. And then at some point in your program flow, you can switch to ROS control. And you can still have it manually. You can have it available on your teach pen and you can see what goes on. And when you're done with doing your vision insertion, or if you're vision picking, or if you're done with doing your custom force control that you've embedded in ROS, you can send the control back to the teach pen and let you continue on your task. So that will also make the whole process of integrating this in a full application much easier for you guys. You could even sort of build up a bin picking system on this platform and ship it as a standalone unit and have your customers work with the robot for all the other stuff, right? Because right now we see a lot of people sort of re-implementing a classical robot teach pendant in ROS to be able to do like the first part of a task or the last part of a task. So that's going to be a new feature. Another thing is calibration. So any UR robot since CB2 is factory calibrated for absolute accuracy. But it's actually not a part of any ROS driver that I know of. I know a few people that sort of extracted it manually. You can even when you connect to the robot, you get all the calibration parameters. So now the new driver will read that out upon connect and update the SARCO, so you'll actually have an accurate URDF. So with Move It, you can actually do proper IK and linear motions and so on. So you won't have to go with the troubles of pushing that back and forth. So the new eSeries. So we released the new robot series as well that also brought a lot of features that we want to push to the ROS community as well. So the lineup is pretty much the same as before on the exterior. So pretty much everything inside of the robots is new. And of course we want to sort of make all these features available in ROS as well. So I'll run through about a lot of that and also show you how you can use that in ROS in the new driver. Right, so one of the key things that came in the eSeries is we have a built-in force torque sensor. It's based on a Robotics technology. We have a much faster control bus now, scaled up from 125 hertz to 500 hertz of control frequency. So if you look at that, so you can actually run the ROS driver complete at 500 hertz, meaning that if you want to do high dynamic stuff, you can do that at quite fast responses. I guess we've discussed real time a lot this morning, and as you can see from a lot of the previous presentation from today, that running at a stable 500 hertz control loop is not that easy. So of course it brings back a lot of demand on the real time implementation, also on the ROS side. But again, now you have the possibility to actually do control like that. We have a tool-mounted force sensor as a standard option on all the eSeries robots. it's the specific sensor that has a very, very high bandwidth. So it's very suitable for doing like impact detection, stuff like that. So you can actually do a lot of tactile feedback tasks with the sensor. You'll be able to see the settling of the sensor in much higher frequencies than 500 hertz. So you won't see any sort of slow decaying. We'll of course publish that as a wrench topic running the full 500 hertz. So on the eSeries, there's also a new feature on the tool communication outlet. So you'll actually have a RS-485 bus going all the way to the tool. And you can draw out 2 amps of peak current out of the tool as well. As we have a force sensor up there, the challenge of bringing on external cables really brings you a lot of challenges, right? So if you're doing force-based applications, you have to deal with the strain of cabling attaching. So if you can shift stuff to the tool by the communication means through the tool connector, you have a much, much easier way of dealing with the robot. So we'll do that by actually forwarding the UART to the ROS machine. So the working assumption right now is we can see we will make a virtual serial port on the ROS machine. So you can actually reuse existing drivers that you have in ROS. You can stack ROS serial on top of whatever you want. So if you want to have an Arduino going up there or anything else, then you do have 10 megabits running through the serial channel that you can play around with at the end. And at least that means that you can have it decoupled from the robot side of the force torque measurements. And as you have 24 volts at 2 amps, then you have 48 watts to also do some power demanding applications up there. All right, so safety. So a huge improvement in the eSeries was well on the safety. So now it's full ISO 10218 compliant, and it is a category 3 safety system. So of course we need to make sure that everything that you do in ROS is also safe. So that will be a standard feature. So one thing is that everything that you do in ROS is still under the safety harness of the robot controller, meaning that as long as you set up your safety settings in the robot controller correctly, it will make sure that you'll stay within the safety limits that you have set. Right? It actually means that it's certifiable safe in the end, that if you can make your application safe with the safety settings that you configure, then you actually have the means of certifying the safety of the solution and CE marking a solution. Of course, the challenge is that the UR safety system will scale any motion that violates safety speeds, right? So if you set a safety limit at, let's say, 150 millimeters per second, then that will be the limit of the motions, right? So if you're assuming that you're just doing feed-forward control and assume the robot will do a faster motion than that, then your target will run away from you at some point. So we'll try to make sure we handle that as much as we can in the ROS driver to make sure we stretch the trajectories that we send. But of course, it also brings the responsibility back to you guys to make sure that you also accept that you can run into a ceiling. So in the ISO 10218, one of the safety requirements there is to have single point of control, meaning that it's not allowed to be able to start your robot from multiple locations. Right, so if you're sitting next to the robot, you want to know if it's the teach pendant that starts the robot or if it's someone else in another room. So if you're using sort of the classical approach, the remote control mode, you need to put the teach pendant and the robot in remote control mode, which means that the teach pendant is now useless. But then again, you can control the robot directly from ROS and you can jog it or whatever you want. But of course, if you actually want to have a switching behavior between the teach pendants or jog the robot around with the teach pendant, you need to go back into remote control mode to actually be able to run the robot in ROS. Whereas if you actually use the UR cap integration mode, then, well, in the end, it will just be a part of the programming tree. So we have ROS control coming in there, and all starting and stopping off the actual robot program will happen manually on the teach pendant. So you, again, have the responsibility to make sure it's safe when you're doing that. So it's probably easier, the last way of working with the robot. All right, so the last thing we update a lot is the easy programming behavior on the eSeries. So, and that pretty much goes back to ROS control as a part of the programming tree. So I just very quickly mocked it up as it's probably going to look. So in the end here, you can build up your whole robot program tree. And then at some point, if you need actual ROS interaction with the robot, you can have like a ROS control programming node. You probably need to set up the target of the ROS and so on. And and we need to look into which kind of parameters do you need to send to ROS to sort of know which kind of feature you want to execute in ROS. Stuff like that still need to be worked out. But I think the flow of using that driver like that will be much more convenient than sort of giving away the full control. Yeah, so that's pretty much the features of the new driver. So we're looking very much forward to it. The work is just started, so we'll be processing that for the next 5-6 months. I think I'll send away a few messages on. So I mean, this has a lot of potential. ROS has a lot of potential right now, also to be scaling into a lot of industrial applications. So I think right now there's still a challenge. So supplying you with one functional driver is one step of the way. But I think also the real-time discussions that we had this morning shows a lot that there's still a lot of things that we need to deal with, right? So there's still a challenge of doing very high bandwidth control from. We just seen that just doing it from a Linux system isn't that easy. Even having the network stack running at 500 hertz is actually not that easy, right? So one of the key things that we need to think about is how do we actually properly handle this barrier between hard real-time and soft real-time, right? Because right now it's very transparent. As soon as you push the decision mode all the way up in a chain, then you're actually raising the hard real-time requirements all the way up in your motion planning or whatever will need to be reacting reactively. We can see it in all sort of computing that more and more control is pushed towards the edge devices. So here there's a lot of applications where you don't need to be feeding the robot at set points at a very high frequency. Actually, maybe you know the whole trajectory when you're done doing like an offline processing of it. So there may not be any reason why the ROS should sort of be iterating through every set point at 500 hertz. So I think in the new driver we'll try to make sure that we push as much interpolation as we can to the robot side of it. But it could be something in the community that we should also address on a more generic level, that how can we make sure that the right decisions in terms of real time is done on the right levels. Because if we want to industrialize this, then we sort of need to settle and figure this out. Missing like a couple of hundreds milliseconds at a very important decision point at some point is not really acceptable for a real industrial use, right? So that's something we have to think about. It's not something we will completely deal with in this driver. So I'll be very open to discussing with the community as well as how do we sort of get this right at some point. And probably shifting responsibility also for the real-time part into the edges here and there, like the robot controller and like we see in cameras nowadays, and so on, maybe one of the ways to go. Yeah, so we'll be beta testing, right? So of course we'll very much appreciate all of your feedback. So if you have any feature ideas that you think we should include in the ROS driver, please let us know. And we'll be running a beta program, so as soon as we have some sort of operational software, we'll be very much interested in providing it to you guys and get all the feedback that we can. Both of them, we created an email address for that, so if you write at ros@universalrobots.com, please sign up for the beta testing, and if you have ideas for the ROS driver, then let us know. Then see if we can sort of fit it into the development plan. Because in the end, we want to give you a feature set that you need, that you can work with. Right, so we're planning on implementing different trajectories and so on, so you can do Cartesian trajectories and joint-based trajectories and so on. But getting all those details right, so we actually match the feature set that you guys want, is important for us. Right? So with that, thank you. Don't forget to sign up for the beta testing.
Thank you, Anders.
Yeah, any questions?
Hi, I have a question. You said that in the safety mode, you want to ensure that only one part is controlling the robot, and that the teaching panel is actually getting useless. So, what is it possible to drive the robot fully without the panel? Like because we're coming from the university and want to put it on a really, really small platform. What's the actual weight of it and the minimal configuration of the UR3, and what do you need to control it?
Yeah, so actually right now, I mean, it's completely possible already now. So we'll embed it into the driver. As I said, for the remote control mode, we also allow you, we'll bring along the functions to actually completely start the robot and so on, so you can take away the teach panel. We have a lot of OEM customers already doing that, so we might as well just bring it to the ROS world as well. So there's nothing at the moment we are doing with the teach pendant that you can't do through all the interfaces. So in that sense, you can start up the robot and you can jog it, just sending speed commands in different directions. Of course, in the end, you have the responsibility also of stopping the robot before it hits stuff, but that's the way if you're a teach pendant. So that's completely possible.
Okay, thanks.
Other questions? There we go.
I think I might be repeating, you already said this, but is supporting ROS-I and ROS-II? And my second question is there a release date for this ROS support?
So release date not completely defined yet, but we're looking at some late spring perhaps. At least we think we'll be having something running at that point. And then depending on how long time the beta testing and stuff like that takes. For ROS-II, I guess that's an obvious question. We discussed that a lot even when kicking off the project, and perhaps we even looked quite interested into ROS-II, also considering the real-time aspects of it. But we actually decided to revert back to ROS-I as everything else is in ROS-I, so all industrial robot support and APIs are right now in ROS-I. So we'll probably do the first release on ROS-I and then have a look at it, and perhaps even ROS-II has matured a bit during the next 6 months. But we'll have it in mind when we write the software. So it's as easy as possible to port to ROS-II, because in the end, having an industrial robot driver in ROS-II makes the most sense. Yeah.
Further questions? All right, so if not, I thank Hannes again.
Thank you.